Good afternoon, everybody. I just wanted to take a moment to thank you and welcome you for coming to our webinar focused on blow molding solution. We're really excited to have you. This is our first webinar of 2021. Can you believe we actually all made it through 2020? It was crazy. Tell you what, though, we have all proved that it is possible to wear sport coats and shorts on meetings. So that's one good thing that came out of 2020. I love that. But we're very, very excited here at Emitted Energy for 2021. We're going to be hosting these webinar series on blow molding and some of our other verticals that you'll be hearing about much later in the webinar today. So we're happy to be a part of this, and I'd like to welcome a couple of guest speakers with us. Typically, you always have to hear myself, Chris Lemons, and Roy Ray, our vice president, talk on these things, but we are excited to have Ernie Hollo of Hollo Plastics with us, and Dragan Grujic, which, by the way, is the coolest name ever. So Ernie, Dragan, welcome. How are you guys doing today?
Hey, thanks for the invitation, Chris. Great to be here.
Thank you, Chris.
Okay, so with that said, we're going to go ahead and get started. So I know Dragan has got over 40 years of blow molding experience, and Ernie Hollo has just about as much. So they've forgotten more than I'll ever know about blow molding. So we're very excited to have them. So let me just start off with a question, just simple Q&A. So Dragan, as a blow molding expert, or as a blow molder just in general, what would you say are one of the things that are most likely hard to control? What is one of the things, if you could get control of, what would that be?
I would like to control Parison length or Parison stretch. We know in blow molding, technicians working with many parameters to produce good products. Once technician has good recipe, it is important to maintain process and continue making good parts. To do that, one of the challenges is to control Parison length and Parison stretch. Monitoring Parison temperature and ambient temperature, measuring delta between them, and taking action, we can control Parison length. With steady Parison length, tooling profile will be accurate and represent desired wall thickness in particular places of the Parison and final parts. So we're going to make good parts.
Okay, thank you, Dragan. I appreciate that. Ernie, can you expound just a little bit on what Dragan was saying? So like, if I understood him right, he was talking about some of the factors that affect the Parison stretch and length. Can you expound on that for us as well, please?
Yeah, you know what you heard Dragan talking to about is how to set up a process and keep it consistent. You know, we've been talking for many, many years about the fact that we are measuring temperature of material in the barrel, even in the mold and finished part, but we've never been able to measure the temperature of the Parison, especially as it's dropping, you know, the entire length of the Parison. The ideal for blow molded parts, as Dragan pointed out, is you want a Parison that's uniformly heated and uniform thickness and uniform wall and not swinging around in the same length from shot to shot to shot. Now that we have this capability, Chris, of measuring temperature and comparing it to ambient and to mold temperature and setting up a delta and actually getting a closed loop, I think the folks are going to be excited about what the potential is here now to help us, especially with this being closed loop, letting the computer do the work for us, be consistent.
Yeah, Ernie, I mean, what we're able to do utilizing this type of technology is set up multiple focus areas around the process that we can take individual temperature measurement points. In our world, we call them regions of interest, but essentially they are vision tools to allow us to take a look at parameters such as the start of the Parison drop, the bottom of the Parison, and try to look at those two temperature variations. We're also able to look at the ambient temperature, as you said, and in the environmental temperatures within the machine or in the environment to be able to compare that to the Parison temperatures to look at controllability. Are we out of control or in control as the environmental temperatures change and flux up and down? So utilizing the technology now allows us to look at not just one temperature reading, but now we can look at a number of different temperature readings. You know, a lot of people use the spot pyrometers and laser digital temperature readout points, but that's one tiny little, what we call a pixel. It's one spot. Utilizing the thermal imaging cameras, now we're able to look at over 300,000 individual spots. So now we can draw specific vision tools around what we actually want to monitor. And now we can look at not only absolute temperature, but minimum, maximum, and average temperature around a certain parameter.
Oh, that's fantastic, Roy. And if I understand correctly, we're also going to save all this data. We're going to report all this data. We're going to use it with the software to close the loop and actually make changes, right, to the equipment?
Yeah, I mean, better said, what we're able to do is actually set up parameters, control limits. So we don't want, if we set up a maximum temperature value and a lower temperature value, now we call those control limits, upper and lower control limits. We're able to ensure that our Parison or our environmental temperature within the equipment is within certain bandwidths. And as it starts approaching to get too hot or approaching to get too cold, now we're able to send that back to the equipment and let's control our process, right? So let's take that information and change our process. So we know we're not going to get into a faulty condition where we're producing scrap or we're producing bad quality of a product that maybe in the past we never even knew that we were producing bad quality until some well down further inspection points and quality assurance points were happening in the manufacturing process. But at the end of the day, what we're able to do is, yes, we're going to record that information, we're saving it, and again, in real time, we're able to set barriers around what that environment should be or what that Parison should be looking like, and we're setting those control limits around that. So let's say, for example, that you have an upper and lower control limit around 100 degrees, plus or minus 20. So up to 120 degrees, down to 80 degrees. And we're looking at the temperature of the Parison, and we're saying, all right, we're starting to get too hot, right? We're increasing, we're getting close to that 120 degree. We're trying to control that, but let's just say we're unable to control that and it breaches that control limit. Now what we can do is we can shut down the process because we know beyond a shadow of a doubt that is producing bad product, bad quality, and now we're able to stop our process. We're not wasting money on scrapped material, and we can get the right resources over to the equipment to figure out what's going on. So there is a lot of control about this, but at the end of the day, what we want is data. What we want is real-time data to make good, smart decisions, and now we have the technology to do that.
The IR camera capability just really gives us so much more flexibility, Roy. I'm really impressed with it. I know we're going to plan some future seminars to talk about things like checking the temperature of PET preforms coming out of the heater and going into the blow section, and even the inside temperature of the mold. And also, we're actually working with a couple of customers on finished part temperature so that we can do planning for fixturing downstream, increasing, decreasing cycle, you know, where we know we can be temperature wise. Those are all fantastic. And I know that's future discussions, but just to get people excited about it, those are the types of topics. And I'm hoping customers will come back with more where we can provide some great information, some great help with the IR technology. And Roy, you know, even before we run out of time here, maybe you could also mention to folks some of the other things the system can do. You know, the IR system, things like preventive maintenance, temperature of heater bands, monitoring electric motors, things like that. That's the type of stuff that folks may not even realize that infrared technology can provide for us.
Sure, Ernie. I mean, when you talk about the scope of a program, right, where we want to be able to measure and control our product, right, our Parison of what we're trying to produce. And we set parameters around that as we discussed. We look at environmental factors. So if someone opens up a door and a gust of wind comes in, or the whole, you know, as you start off in the morning, your plant temperature is typically a little cooler, but as you start running for a large period of time, that plant temperature, that environment, those temperatures raise. I mean, all these machines are working, and you know, the heat of the day outside of the building, I mean, we all warm up. So what we're able to do is run a delta off the environment temperature and try to regulate that manifold to bring those temperatures back into line. So that's the beauty of it. But talk about project scope of or project creep of what you're just talking about, gold plating is what I call it. Now we're able to look at some additional things. I told you that we could have up to over 300,000 individual temperature measurements. So let's put some of that to use by now let's look at the manifold. What temperature should that manifold be running at, and try to correlate that and control that information. Let's look at any kind of motors within the in the assembly equipment or the processing equipment, and be able to monitor that to make sure we don't have premature failures. What we do know is that when you look at pumps and motors and switches and electrical control panels, what we do know is that or looking at failures prematurely, they start to rise in temperature. So now what we're able to do is look at specific areas around the equipment and put those control limits. So if we start seeing temperatures rise in your equipment and your machine, now we can alert someone to come over and take action on what is going on before the machine just shuts down. All right, and that's a very popular approach.
So that's really, it's a really good thing to bring up, Rory. Thank you for bringing that up. Dragan, I know when we were doing this case study a few months ago on this blow molding solution, you had mentioned a couple of real life scenarios that happened to you. And I know, Dragan, you got a lot of yours. So can you just take a minute and kind of give us an example of how what Rory just said, monitoring multiple aspects of the tool, monitoring manifold or nozzle or Parison, multiple areas of the Parison and the deltas between the two. Can you just give us a real life example of how that would help you and maybe some of the things that you've encountered yourself as a blow molder?
Well, in my experience, I had a situation that during the day, ambient temperature raise a lot, and in the morning, usually we are making good parts, but afternoon we started having problem and we couldn't control machine. And sometimes afternoon we had actually even to stop machines because the Parison was stretching and tooling profile on the machine which we have didn't represent real situation, and we had variation in the wall thickness on the final product part. So we had situation that we had actually to find a way how to cool area around the machine so the Parison wouldn't stretch so much and control variation in production and increase the quality.
So thank you, Dragan. I appreciate it. So what you're saying is you are reactive. Our systems could help you to be proactive.
Yes.
Okay.
Dragan,
So
you brought up a good point on. No, I'm sorry, Chris. I was just going to say, Dragan, you brought up a good point about that Parison stretch, right? If our environment gets too warm or our manifold is producing too much heat on the Parison, we're going to have too much stretch in that plastic. What if I were to tell you we can put a vision tool in there that will alarm us if we have too much stretch happening, right? So now I can use the thermal imaging camera to put a wall or a floor, I should call it, a floor that says if I reach that floor, now I have too much stretch. Now, again, all the other parameters might be able to give us that information of why it happened, but certainly we don't want to have it stretch below that floor. And from a vision tool perspective, now we have the capability of putting gross hard limits. We cannot have a Parison drop too far down and past our floor. We cannot have it drop, again, too fast, maybe, or too slow. So there's a lot of things that we can do with those vision tools to be able to give us real-time, real data without in an integrated system, so we don't have to keep trying to chase our tails of figuring out why are we producing bad product.
And I love the data aspect of what you're talking about with the, I'm sorry, Ernie, I love the data aspect of what you're talking about, Rory, because I came from manufacturing. I have over 20 years of experience of pushing buttons myself, and it was always so frustrating. It just seemed like we never had data. When we had a quality issue, that's when everybody jumped in and was gung-ho to fix it. And then you would have to find the data. Wouldn't it be so nice to have that data? So what you're saying is the data stored on the manifold, the nozzle drop, the Parison, all of that is separate data that you can procure simply from our thermal process monitoring system, pull it via CSV file, and run an SPC trending chart at any time.
Absolutely. Not only will we be able to see that real time, Chris, now we can log that information. Now you have, according to your personal or your company's data retention policy, what we're able to do now is be able to store that data. So now you're going to be able to look at the last 8 runs, the last 160 runs, or the past 30 days of analytics and data. So that now you can pull all that in, and now we can look at how are we doing from a trend perspective over the last 600 bottles made, or the 600 pieces of product that have been made. Are we trending in a positive direction? Are we within control? I talked about those control limits. Are we within those control points? So again, having that type of data, having an access right at your fingertips to be able to make those decisions and try to not only make sure the equipment works as designed. Now we're able to look at and really use that information to look at root problem analysis if there are problems. Machine 3 may be running better than machine 4, but how do you really know that? Now we have data to be able to answer those tough questions.
And Chris, what I was going to say earlier there, we're talking about a solid floor or a position coming out. The fact that we're actually measuring the temperature of that Parison, Roy, before it comes to that set, the bottom point, we can estimate when the temperature is changing that it's going to go beyond the shot size. Now that we're monitoring temperature, we know what temperature works and what temperature doesn't work for the part. And that's something that I don't think even the resin manufacturers know. They'll tell you you're supposed to process this nylon at this temperature, this high density at this temperature, and we know that, but we don't know what the temperature really is of the Parison. We only know what it is inside the machine, where we can measure with thermocouples. Now we really have absolute control of that because we're looking at the temperature through the entire Parison, so we know what's causing it to get longer or shorter, whether it's the environment or the machine putting too much temperature or not enough in there. It'll really help us processing to get within a much tighter window. Means less scrap, means faster cycle times, better quality parts. I mean, it's really well worth it.
Oh, Ernie, I love it. I was told you were a smart guy, but you answered my question before I even asked it. I was going to say, what's the difference between this and simply placing a pyrometer at the top and the bottom? And you just answered that question.
Hey, and it's not that I'm smarter than anybody, just that I've already made the mistakes, and I listen to a lot of people who know, like Dragan.
Well, it brings up another point, guys. I mean, when you look at this and you start saying, how do you even set up a machine? How about a tool? How about a machine builder trying to do runoff? Is it a hunt and peck game? How many parts do we have to run through before machine sign off to be able to make sure we have the right parameters? Because I'm sure that when the machine's packed up and shipped and got to the customer floor, when it gets started up again, we have to go through the same process. How many weeks and weeks and weeks are we chasing a perfect Parison when we don't have the real data to be able to quickly adjust on the machine, right? So we're just running through scrap, and it continues until we find that perfect combination of all your dials and buttons and switches. And once you find that perfect recipe, you're like, stop, we got it. I think this is it. And it's going to move, right? It's going to exactly. We have more variables. So how do we ensure that without the data, it's like you're trying to walk through a room in the dark and you're just feeling around the walls until you find that door. Using these TPMS and camera systems, maybe that's your flashlight in a dark room.
Roy, I think in today's marketplace, this is going to be even more helpful because molders are finding it harder and harder to find young kids that they can train. So we need all the help we can get from the technology side, because we're unfortunately losing a lot of that great experience. The guys know just what little bits changes to make a good part.
Yeah, that's a good point.
We had a situation that adjusting the process and correcting some parameters, everything was depends on technician and experience which he has. Now we are going to have some information which can help us even to predict what can happen if the temperature rises above some limits.
Mm-hmm. Yeah. It's a great point, guys. Thank you so much for bringing that up. Hey, I know we're quickly running out of time, but let me ask you this, Ernie. You had briefly touched on it. Can you just kind of let us know, help us out a little bit on how could these systems better improve processes related to PET and stretch blow?
Yeah, we're focusing here on extrusion blow because we're looking at the Parison, the temperature of the Parison, which is revolutionary, by the way, in our industry. I don't know anybody else who's done it. We've talked about it for years. But the same technology, like we're talking about, Chris, we've talked about this before. For PET, just one example, the temperature of the bottles coming out of the heater going into the blow station. We can tell if there's even the smallest of changes there. And we know when the heaters are starting to go bad or where we need to adjust. And again, we can close the loop on that, which is fantastic. We can do the temperature now inside the mold. Every time the mold opens, we can get the temperature inside there, and we can compare that, Roy, right, with the temperature of the Parison and the ambient temperature, and make that one of our parameters to be watching. And also, like I mentioned, we're working with a customer right now, measuring the temperature of finished parts coming out of the machine. Where do we measure it? Do we measure it as the mold opens? Do we measure it at a secondary blowing station? Do we measure it on the conveyor, or do we measure it in a fixturing? If we can do things like that, we can decrease the cycle time, hopefully decrease the part weight, which will really save us a lot of money and allow us to be able to have better quality parts. So those are just a couple of the ideas. And I'm really hoping the folks that are watching the webinar are going to say, hey, what about this? And what about this? Hey, you didn't think about this. And then those for future webinars, if we could help. And of course, we can call people and help out directly. You've got the equipment right there at your facility. You might want to tell folks about it. It's there, it's available. We can do the testing. You have tremendous flexibility with the camera technology that you have there. We could have 100 cameras on the machine if we wanted to, high speed, low speed, whatever. You guys know better than anybody. But I think we have a tremendous opportunity here, fellas, for the industry to show them things that are going to help them dramatically with the bottom line.
No, absolutely, Ernie, and thank you. We appreciate it. I appreciate you and Dragan taking time out of your busy schedule to join us for this very first blow molding webinar. I know there's going to be many more in the future. Just a little bit about Emitted Energy. For those of you who don't know who we are an infrared technology company. We focus on providing solutions that will control and analyze your industrial manufacturing process. This webinar was focused on blow molding. However, every month we'll be having another webinar on focusing on another process related to industrial manufacturing. If you guys would like to get a virtual demo, we are offering these per the schedule. We're going to leave the chat room open after this webinar for about 15 minutes. If you have any questions that you didn't hear us discussing during this webinar today, please feel free to chat those to us. We're going to stay online and we're going to answer all of your questions. Also, if you would like a virtual demo, chat that in there as well. We've got your name on the register. We'll be following up with you and scheduling those virtual demos. If you are accepting visitors in your plant, I or Roy would be more than happy to come to your facility and give you a demo in person. So on behalf of Emitted Energy, Dragan, and Ernie, thank you very much for joining us today.
You're welcome.
Thank you.
Absolutely. And we would like to, like I said, leave the chat room open for just about 15 minutes. And then we also wanted to make you aware that Emitted Energy on the screen here, you're going to see the 7 different verticals that we have. So those are, if any of those are your processes at your facility, please feel free to contact myself or Roy Ray at Emitted Energy. And you can also visit our website at emittedenergy.com to procure more information and learn more about our solutions. Outside of this webinar, we look forward to having you on some of the other webinars that we offer, and just wanted to say thank you very much for taking time out of your day. And thanks again to Roy, to Dragan, and to Ernie for joining us today.